Hello everybody and welcome to my channel, and this is Vibha and you are watching BS Chem Club. So in my previous video I was discussing about the preparation of haloalkane and haloarenes, and it is haloalkane and haloarenes are prepared from four possibilities way, that is from haloalkane, from hydrocarbons, from alkene and from Halogen Exchange reaction. In my last video, I was discussing about how from alcohol we can prepare haloalkane and haloarenes. In this video, I will cover how haloalkane and haloarene preparing from hydrocarbons, alkene and halogen exchange reaction. So let's begin. Okay. The first is from hydrocarbon. From hydrocarbon, there is also three possible way we can prepare halogen or alkyl halide and aryl halide. First is from alkane. Second method is from electrophilic substitution reaction. Third is from Sandmeyer reaction. So we will go step by step. First from alkane, then from electrophilic substitution reaction, from Sandmeyer reaction we will prepare haloalkanes and haloarenes. So first check from alkane. When alkane undergoes halogenation in presence of light, here Hnu is the light, and this alkane undergoes free radical halogenation. So what we will get? We will get a mixture of haloalkane, that is this is propane, and the product is 2-chloropropane, and this is 1-chloropropane. So when propane undergoes free radical halogenation, that one hydrogen of the propane is replaced by halogen atom. So let's check how the mechanism of this reaction. Mechanism: chlorine Cl bond, when in presence of light, this bond electron shift, one electron shift to this chlorine and another electron shift to the another chlorine. So basically we will get 2 chlorine free radical. This is chlorine free radical, and this chlorine free radical attack to hydrogen of the alkane. So one bond shift here, one electron shift here, one other electron shift here. So the product is CH3 CH2 CH2 dot plus HCl. This is propyl free radical, and this propyl free radical attached to this chlorine and make a bond to form one chloropropane. Again I have to say, here in presence of light, this chlorine bond are break homolytically. So one chlorine radical and another chlorine radical is free radical is formed, and this one chlorine free radical attack to the one hydrogen atom and a propyl free radical is formed. That propyl free radical react with another chlorine free radical and make a compound that's name is 1-chloropropane. In the same way, 2-chloropropane also be prepared. This is from alkane. Next reaction is electrophilic substitution reaction. First of all, we should know what is electrophilic और what is electrophile. तो electrophile क्या है? The electrophile is a neutral or positive atom or group of atom which can accept a pair of electron in their vacancy orbital. So basically these are like H3O plus, AlCl3 and FeCl3, like this. So basically this aluminum trichloride and ferrous trichloride are accept a pair electron, so that they are called electrophile. And what is substitution reaction? The substitution means when a atom or group of atom replace another atom or group of atom, so that type of reaction is called substitution reaction. When a atom or group of atom remove a atom in a compound. Let us check. If this is methane, H. If this methane contain 4 hydrogen, so if one of the hydrogen is replaced by another group like Cl, if Cl replace that hydrogen, then what is the compound? The compound is Cl H, that is methyl chloride. So here one hydrogen is replaced with chlorine, that means one hydrogen is substituted with chlorine, that is substitution reaction. In the same way, if a electrophile substitute one of the atom in the reagent, so the compound is called substitution reaction. Let's check what is the substitution reaction. This is toluene. When toluene react with Cl2 in presence of FeCl3, it gives a mixture of ortho and para chlorotoluene. This is ortho chlorotoluene and this is para chlorotoluene. So that means when a toluene react with chlorine in presence of a Lewis acid, FeCl3 is a Lewis acid, or it is a accept a pair of electrons, so it is called Lewis acid, and the product is orthochlorotoluene and parachlorotoluene. So how exactly this compound is formed? Let's check the mechanism. Mechanism. When FeCl3 react with Cl2 or ClCl, that one of the Cl is FeCl4 minus and Cl plus. So here Cl plus is the electrophile. Then that chloride ion is attacked by phenyl group. That benzene ring contain 3 pi bond, so that one of the pi bond is attacked to this chlorine. It may be attacked from this side or it may be attacked from this side. When then there is two possibilities. When attacked from this side or ortho side, we will get this type of intermediate. When the chlorine attack from the para side, then we will get this type of intermediate. This is also plus. Here benzene lose his aromaticity. So to retain that aromaticity, that hydrogen atom give that 2 electron and leave as a plus ion. So the compound are CH3Cl and this compound is Cl, and this compound is called orthochlorotoluene, and this is called parachlorotoluene. So basically what will happen, as FeCl3 is a Lewis base, it can accept a pair of electrons from chlorine, so that FeCl4 minus is formed and Cl plus is formed. That Cl plus is a electrophile which is attacked from a nucleophile, that is benzene ring is a nucleophile. That benzene ring contain pi electron, so that pi electron attack to this electrophile, and this intermediate is formed. In that intermediate, benzene lose their aromaticity, so that hydrogen atom loses give his electron to retain the aromaticity of the benzene ring and leave as a S plus. So orthochlorotoluene and parachlorotoluene is formed. This is the electrophilic substitution reaction. Okay, let's go to the another reaction. Next is third type of reaction from hydrocarbon is Sandmeyer reaction. It is a well-known reaction for preparation of aryl halides and allyl halides like allyl iodides, allyl bromides, and allyl chlorides. Okay, so this reaction is started from primary amine. So this compound is called aniline. When aniline react to it in presence of Na, NO2 plus HCl at 273 to 278 Kelvin, or that is 0 to 5 degrees Celsius. This is sodium nitrite with HCl at 273 to 278 react with aniline. This reaction first make benzene diazoxide chloride, that is N2 plus and Cl minus, that is called benzene diazonium chloride. When benzene diazonium chloride react with cuprous chloride Cu2 Cl2, it gives chlorobenzene. This is chlorobenzene. So this is the Sandmeyer reaction. When primary amine or aniline react with sodium nitrate and HCl at 273 to 278 Kelvin, it gives benzene diazonium chloride. Benzene diazonium chloride when react with cuprous chloride, it gives chlorobenzene. In place of cuprous chloride, we also taken as cuprous bromide, so that we can get bromobenzene, right? So this is the Sandmeyer reaction all about. So let's begin the mechanism of the Sandmeyer reaction. Mechanism. First of all, in the first step, Na2 react with HCl. In the reaction, sodium chloride, that Na and Cl are make sodium chloride, and NH2 NO2H are form nitrous acid HONO. That compound is like that, N double bond O, single bond OH. Here the nitrous acid is protonated, that OH is protonated by H plus, so that H2 is removed and N plus double bond O plus H2. So in this step, that OH group is protonated with H plus, so that water is released, so N double bond O plus is formed. That is nitrosonium ion, that is a electrophile. It is a electrophile, and that ion is called nitrosonium ion. So basically that nitrosonium ion is attacked by a nucleophile, or basically that NH2. Nitrogen contain one lone pair, and that lone pair attack to the N plus O. So the compound is benzene N H single bond N double bond O. So basically this intermediate is formed. In this intermediate, that OH, O oxygen, and this H is make a water molecule, and N triple bond N is formed, and this compound is diazonium ion, and this compound, that positive ion is neutralized by one Cl minus ion. So that compound is called benzene diazonium chloride. So this is the benzene diazonium chloride. So up to here we prepared the benzene diazonium chloride. How? Let's check again. Sodium nitrate HCl react to form HONO, or it is called HONO, and that OH group is protonated with H plus and give a water molecule, so that electrophile is formed HN plus double bond O. So that is called nitrosonium ion. That nitrosonium ion is attacked by electrophile, nucleophile, that nitrogen contain a lone pair, so that lone pair attacked to the NO plus and make intermediate, and that time water molecule is released and benzene diazonium chloride is formed, and that benzene diazonium chloride when react with cuprous chloride, it gives chlorobenzene. In place of cuprous chloride, if you will take bromine, we also get bromobenzene. And also in place of cuprous chloride, if we will take potassium iodide, we also get iodobenzene. This is iodobenzene. This is the overall Sandmeyer reaction, mechanism of the Sandmeyer reaction. Okay. Yeah, from next. Next is from Alkene. From Alkene we prepare Haloalkane and Haloarenes. So when alkane react with HBr, it gives CH Br CH plus CH Br. Basically we find two isomer. One is 2 bromopropane and 1 bromopropane. When propene react with HBr, it gives 2 bromopropane and 1 bromopropane. In this is 2 bromopropane, 1 propane. But 2 bromopropane is the major, while 1 bromopropane is the minor product. So here the question is arised, why 2 bromopropane is major product and why 1 bromopropane is the minor product. So there is a rule called Markovnikov's rule. Marconi groups. What is Marconi group rule? Marconi group rule is when a halide attack to the alkane, that double bond is break and that halide group attached to the carbon which contain less number of less number of hydrogen. Marconi rule is the negative part of the reagent, that is Cl, Br, etc. are attached to the carbon atom which contain less number of hydrogen. If we consider this propene as our reactant and HBr is our reagent, so HBr contain H and Br atom, so H atom is attached to the more number of hydrogen carbon and Br atom, that bromide radical, that bromide ion is attached to the carbon which contain less number of hydrogen. That means this second carbon, this one first carbon, this is second carbon, this is third carbon. So that Br is attached to the second carbon. So that product is 2-bromopropane. So the major product is 2-bromopropane. Now you understand? So if the same reaction is proceed under peroxide, let us consider that reaction CH3 CH double bond CH2 plus HBr. If the same reaction carried out under peroxide, what is the major and what is the minor product in this reaction? Here the reaction major product is CH3 CH2 CH2 Br, that is 1-bromopropane. Plus the minor product is, this is major and minor product is CH3 CH CH. Minor. This reaction is also called peroxide effect reaction. What is happened here? Here there is an anti-Markovnik's rule. That Markovnik's rule is not followed for this reaction, because in the presence of peroxide, that Br atom, that bromide ion, is attacked to the carbon atom which contain more number of hydrogen, and hydrogen atom attached to the carbon which contain less number of hydrogen. That is the opposite of the Markovnik's rule. That is called anti-Markovnik's rule. In peroxide we follow the anti-Markovnik's rule. In absence of peroxide, in general reaction we follow the Markovnik's rule. So then what is anti-Markovnik's rule? Anti-Markovnik's rule is opposite that of Markovnik's rule. The negative part of the reagent. What is the negative part of the reagent? That is Br minus Cl minus attached to the carbon atom which contain more number of hydrogen. These are the two rules we follow for when we prepare haloalkanes from alkane. In alkane, in alkane there is two position we can attach halogen atom. If we react with HBr, so there is two possible way we can attach this bromide ion. We can put it here, we can put it here. But which is preferable? If there is no peroxide effect, then we can preferable that carbon with less number of hydrogen. That means that is middle carbon. This carbon will attach that bromide ion. If there is a peroxide ion, or if there is a peroxide effect is there, then that bromide ion attached to that carbon with more number of hydrogen. So the product is here RCH. Here, in absence of peroxide, but in presence of peroxide, the reaction is CH2. Now you understand what is Markovitch, what is anti-Markovitch, and how alkene prepare haloalkane from with reaction with HBr. Right? Then next reaction is first is Schwarz reaction. Then Schwarz reaction is generally prepared for alkyl halides, especially for alkyl fluorides. So in the first reaction, that if methyl chloride react with silver fluoride, it gives CH3 F plus AgCl. So basically, when methyl chloride react with silver fluoride, it gives methyl fluoride plus silver chloride. In this reaction, that silver chloride is precipitated and methyl chloride is obtained. This is methyl chloride and the product is methyl chloride. The Schwarz reaction is basically exchange the halide exchange reaction. Here one chlorine atom is exchanged with one fluorine atom. So this is the all about Schwarz reaction. Then is Finkelstein reaction. Next reaction is from Finkelstein reaction. Finkelstein reaction. This is a basically preparation for alkyl iodide. Finkelstein reaction is a halogen exchange reaction. In this reaction, we can prepare alkyl halides. So, if when there is a C2H5Cl, when is a ethyl chloride react with sodium iodide, it will give C2H5I plus NaCl. In this reaction, halogen atom, that iodine is replace the chlorine, so that we will get ethyl iodide from ethyl chloride. So in Frankel style reaction we will get iodide. This is reaction basically for alkyl iodide, right? So this is all about the preparation of haloalkanes and haloarenes, and I hope you like this video. If you like this video, please share with your friends and